Hi students, today we will discuss the functional unit of a computer. In the last classes, we have already discussed what is the role of computer, and as we know that computer is an essential part of our life. So today we will discuss the functional unit of a computer or a block diagram of a computer. So this is the block diagram of a computer. Mainly it is having three basic building blocks. As we can see, the IO devices. IO devices are used to provide the input and input to the processing unit. As we can see that it is a functional unit of a computer. The basic block diagram of the computer is having three basic blocks. It consists of CPU, which is a central processing unit. This is the heart of the computer, which is used to perform all the computing related operation of the computer. IO devices. The role of the IO devices is to provide the input and to take the output whatsoever the processed data will be performed by the CPU. The role of the memory is used to store the data temporary or permanent. So in the detailed discussion, the role of the input device is to provide the input. Whatsoever the data we want to manipulate or we want to supply to the CPU, that data will be supplied through the input devices. There are so many input devices are available. Some are keyboard, touchpad, mouse, scanner, mic, camera, joystick, and trackball. All these are the generalized input devices which use to provide the input to the computer. Output devices. The role of the output devices is to display the results. Whatsoever the data will be manipulated by the CPU or a processor, that will be displayed on the output device through this IO devices. Generalized IO devices are monitor, printer, etc. The heart of the computer is CPU, which is nothing but a central processing unit. It is also called a processing unit or a microprocessor. The role of the CPU is to perform all the computing related operation of the computer. It is mainly further divided into two parts: ALU, timing and control unit. The role of the ALU is to perform all the arithmetic and logical operations of the computer. It will be a block which is responsible to perform the computing operations of the computer. Another part is timing and control unit. The timing and control unit is used to provide the control signal for the different operations. What type of different operations we want to perform, that control signal will be provided by the timing and control unit, and the timing of that operation, at what time operation will have to be performed. For example, if processor want to read the data from the input device, then this timing and control unit will send a controlling signal to the input device, which means now the processor is ready to receive the data from the input device. After receiving the control signal at fixed time, the input device will provide the data to the processing unit. The third important part is memory. So the role of the memory is to store the data temporary or permanent during the execution or after the execution of the program. So there are so many types of memories are available. Mainly are primary memory, which will be the main memory of the processor, which used to store the data temporary or permanent. Cache memory, this will be the fastest memory and it will be the nearest memory to the processor. Processor will assess whatsoever the program the set of program which processor will have to execute many times will be stored in the cache memory. Secondary memory will be the main memory and optical memory. So these are the different types of the memories which are used to store the data temporary or permanent. The fourth block which we can see is the interconnection network. This is nothing but will be a block which will be responsible to interface all these three basic building blocks to each. So the role of this interconnection network, or sometimes it can also be called as interfacing network, which will be used to interconnect or interface the input, output, memory and CPU to the CPU. So as we can see that three types of lines are shown for interfacing network. These are the address, data and control line. So all these units are interfaced through the address, data and control lines or wires are called buses. So whenever we want to transfer or receive any information from any source to any destination, then three types of buses are always required. Address lines, which are used to carry the address, data line, which will be used to carry the information, and control lines, which will be used to carry the actual information which we want to transfer or receive. Now we will discuss the function block diagram, units of the function block. Now we will discuss each and every unit in detail. So first one is the processing unit. This is a CPU, central processing unit. As we have already discussed, it is the role of the central processing unit is to perform all the computing related operations. So for a computer, all the computing operations such as arithmetic operations, logical operations and controlling operations will be performed by the central processing unit. Another name is microprocessor. It is also called microprocessor. So it is also used to perform the information stored in the memory. Whatsoever the data is stored in the memory or coming from the input device, so if data will have to be manipulated or perform any computing operation, then this particular unit, which is called a central processing unit, will be responsible to perform all these operations. Next is the input output devices. The role of the input output devices is to provide the information, is to provide the data, is to provide the data to the CPU. So it is used to provide a means of communication with the CPU. So whenever CPU want to read the data from the input device, it can send a control signal and address of a particular input device. Then the information will be moved from the input device to the central processing unit. So whenever processor want to write the data to the output device, then information can be sent to the output device as well. So any information, either CPU want to read the data will be read through the input device. Whenever CPU want to write the data to the, or whenever CPU want to public or display the result, that will be displayed on the output devices. Third is the memory. Memory is used to store the data temporary or permanent during the execution of the program or after the execution of the program. Anytime computer can or CPU can store the memory is used to store the data temporary or permanent. Whenever processor want to store the data either temporary or permanent during the execution of the program or after or before the execution of program, data can be stored to the memory. Mainly the memory will be of two types. One is called RAM, which is a random access memory. This particular type of memory used to store the data temporary during the execution of the program. It is a type of volatile memory. The meaning of the volatile memory is whenever power will be switched off or computer will be switched off, whatsoever the data will be stored in the RAM, it will be lost. Another type of memory is called read-only memory. The role of the read-only memory, another type of memory is read-only memory. The read-only memory is used to store the data program, any information, any data, which is essentially required for the operation of the computer. So whatsoever the data will be stored in the ROM cannot be changed by any use. We cannot change the data of the ROM, data of the read-only memory, as its name is indicating that it is read-only memory. So whatsoever the set of program we want to store and we want to repeat many times, that particular set of programs will be stored in the read-only memory. So it is this particular type of memory is a non-volatile memory. So which means even if the power will lost, even if the computer will switched off, the data or information stored within the ROM will not be lost. It will remain same. Now we will discuss the role of the address, data and control lines. So as we have already seen in the basic building block diagram, all the different blocks are interfaced with each other through the three types of buses: address buses, data buses, and control buses. So now we will discuss the role of the each and every type of buses. The CPU or a processor is connected to a memory and I/O devices through a bunch of wires is called buses, which are used to carry the information from one place to another place. So whenever we want to transfer the information from source to destination, that particular information will be transferred through the three types of buses, will be transferred due to three types of buses: address lines or address buses, data buses, and control buses. What is the role of the address buses? Address buses are used to carry the address of the source or destination. It may be any input device, it may be output device or memory. So whenever processor want to transfer or receive the data either from the input device, output device or memory, it will have to transfer the address of that particular source from where it want to read the data. Or even if the processor want to write or store the data to the output device or to the memory, it will have to send a unique address allotted to each and every output device or each and every memory location, either RAM or ROM. So the role of the address buses are to recognize any I/O device. So it is used to recognize or identify any input or output device or any memory location of which is connected to the processor. So address lines or addresses will always be generated by the CPU, and those generated addresses will be transferred or moved to the required destination through these address buses. So each and every either input or output device or a memory location must have a address, and that particular address will be unique address. That particular address cannot be allotted to whatsoever the address will be assigned to one IO or memory cannot be assigned to the another IO or memory device. So processor will always send the address on the address lines, and whatsoever the decoder is inbuilt within that particular circuit will be used to find the respective address of the device. So if whenever there will be a bunch of memory locations will be there in memory, then the role of the decoder is to decode that particular address and highlight that particular location so data can be transferred or received. So either we want to transfer or receive the data, that will be decided by the control line. If read control signal will be sent by the CPU, it means now CPU want to read the data from the memory or input device. Whenever the control line write will control signal, whenever the write control signal will be sent by the CPU, it means the CPU want to write the data to the output device or to the memory. Now we will try to understand what will be the impact of number of address lines. What is the meaning? What is the significance of the number of address lines? What will happen if a processor will be having X number of address lines and another processor is having Y number of address lines. So if the number of address lines will move, the meaning of this is that particular processor can assign more number of addresses. And how the number of addresses can be assigned, that can be assigned or calculated by using this equation. 2 raised to power m is equal to n, where the m will be the number of address lines and n will be the number of addresses can be assigned through m number of address lines. So for example, if a processor is having 10 number of address lines, what does it mean? The meaning of this is 2 raised to power 10 will be equal to 1 kilo. So which means a processor which is having 10 number of address lines can assign 2 raised to power 10, means 1 kilobytes of addresses can be assigned to the different input, output or memory locations. So now if the number of address lines will be increased from 10 to 11, then 2 raised to power 11 will be 2k. So even if we will increase the one address line, then the addressing capacity of the processor will become double. And even if we will reduce the one address line, then the addressing capacity of the processor, means the number of assigned addresses, the capacity to assign the addresses is called memory capacity. So memory handling capacity will be half. Okay. So by using this equation, we can calculate the memory capacity of any processor. So in other words, we can say that the number of address lines are also used to assign the memory capacity to the processor. One more thing we need to keep in mind, the address lines or address buses will always be unidirectional, because the addresses will always be generated by the processing unit. So processing unit will have to generate the addresses for the source or destination. This source may be input device, output device or a memory location from where it wants to read the data or write the data. So that is why the address lines or address buses are always unidirectional. Next is the data buses. So what is the role of the data buses? Data buses are used to transfer the data, whatsoever the actual information processor want to transfer or receive from the source or destination is transferred through the data buses. So what is the maximum data handling capacity? What is the maximum data transfer or receive capacity of a processor? That can be calculated through by knowing the data lines of the processor. So the data lines are also used to indicate the data handling capacity of a processor. So if we will increase the number of data buses, if we will increase the number of data buses, the meaning of this is we are going to increase the cost of the processor, and naturally if the cost of processor will increase, automatically the cost of computer will also be increased. And the third thing is the data buses are always bidirectional, because CPU will have to transfer or receive the information from or to the destination or source. It means the data buses must be bidirectional. Whenever processor want to receive the data, in that particular case, the data will move from the input device to processor or memory to processor. It means at that point of time, these data lines will act as input data. So whenever processor want to transfer the data to the output device or to the memory, then the mode of transfer will be output from the processor to the output device or to the memory. So that is why the data lines must be bidirectional. Whenever processor want to read or write the data, data can be transferred or received through data buses. The last is the control buses. The role of the control buses is to carry the control signal. The control signal will be transferred by the timing and control unit of the CPU. The CPU will transfer the control signal through the control lines, which will be used to decide the type of operation. what type of operation a CPU want to perform will be decided by the type of control signal. If the control signal will be read, then it means processor want to read the data from input or memory whatsoever the address will be there on the address lines. So accordingly, either input or memory location will be selected, and then control signal will decide either processor want to read or write the information from the input device or memory. Then accordingly data will be transferred or received through the data line. So this is all about the function of each and every block of the microprocessor.